Hello everybody and welcome back to another video. So, again, kind of late at night here, but we're looking at yesterday's severe weather event that kind of ravaged northern Illinois here, a little bit of Michigan, kind of widespread damage. So I'm gonna look over here a little bit of what happened yesterday. There's gonna be another video I'm making about this pretty soon because I kind of chased it a little bit, not too much, but I got some footage, so I'm probably gonna be sharing that in a video later this week at some point or in the near future. What I really wanted to look at today was just kind of what happened, a little bit of the meteorology behind this. Also, why we didn't see a tornado risk in the south bit. I'm gonna look for a past. I'm gonna have to look for a past report, a past enhanced outlook that was out. SPC had an enhanced risk that ended up stretching up here in Illinois, then another one down in Indiana. So we're really looking at that as well. But without further ado, let's get into it. So we saw this map a lot day of the event. This is 18Z HRRR for 27th, so this is basically 6 hours before everything starts, somewhere around even 3 hours for some of the storms. But the HRRR was showing was a few little bits and pieces right up here, kind of a stronger line segment here near southern Michigan, and a few discrete supercells in southern Indiana. Part of why the SPC, I think, issued an enhanced risk. I'm going to kind of draw it out here. So basically, they had an enhanced risk somewhere along this corridor of a 10% hatch for tornadoes. So anywhere within this area right here, there was a 10% risk of a tornado within 25 miles at that point, and the tornadoes would be EF2 to EF5 intensity, 10% risk in that way. They also added a little, I believe, another 10% risk somewhere kind of like this, which I was in myself. Like another 10% hatch region. There was also I believe a 30% hatch region up here, kind of like that for hail. So basically, the main threat was closest to the surface low, which was centered somewhere around here. A very quick cold front, kind of a warm front stretching up. The warm front's not as important because basically we were seeing warm temperatures over this entire region. This cold front was really our main forcing, and it was basically creating a bunch of updrafts popping up all over the place, which I'll show in the radar loop in a second here. And they had a 5% risk, I believe, basically centered over all this, with the exception of this region right here. So the shape was very strange. It kind of looked like a bow echo itself, and I'll get a picture of it pretty soon. There was this notable gap right in this section, which I'll explain as well. Also to mention, this is also talked about by me in my forecast way ahead of here. I won't look into this too much. I'm going to use this in a bit as well. So right here we have our outlook. It's a little bit hidden under here. Let me see if I can find a better one. Here's our 20Z day one outlook. So at, what is this? I believe 2 p.m. Central Time, there was this enhanced risk up here, kind of how I shaded this enhanced risk down here. But again, there's this notable gap in this region right here. And the fact that when we look at what actually happened with this event down here, we can see the tornadoes really were more so up here in Illinois. Nothing happened down here in Indiana. That was basically one of my main concerns, and I do understand also why this happened as well, which I'm about to look over as well. A notable difference here, there was a tornado. That's a really big marker. There was a tornado here in Ohio, or at least tornado reports, so that kind of fits in the enhanced risk. But the Indiana threat that was originally forecast did not come to fruition at all, and I believe the enhanced risk up here in Illinois was also way better done. Definitely should have probably been a little bit more north though, but they also can't be perfect. They're humans too. Just a little bit of the looks of the storms as well. I don't want to go too in depth into this because it's not my pictures or anything, so I don't really want to be taking without credit. But you can see here a little bit of damage. I mean, pretty fairly significant. Could be high end EF1, maybe EF2s. I believe preliminary right now they're looking at EF1s, but yeah, those are the main threats at the moment with how that actually how that actually happened. I'd also got some satellite data, which I was able to archive. One thing I was going to say was when I was looking at this event, I have this picture right here. This is what I was looking at, and I was like, look at this region right here, right? There's a good amount of CAPE. This is the GFS, I believe, 2 days before the event. And what I was really looking at was this plume of cape that would occur right here in eastern Illinois. If you look at my little radar loop I have right here, kind of see if I can let it play right. Right before it goes dark, there's this little bubbly cumulus field right in here. Usually bubbly cumulus is kind of what like forms right before they form what they look like. And you'll see that kind of continue through the day. Press play again. This is like the end of the, going into the early evening. Once the sun starts setting, these just die out immediately. You can also see our storms up here in northern Illinois right as they're basically forming. So here's our kind of like, that's kind of our cold front back there, I think. We can see again that bubbly cumulus right here. So right before the event, let me see. Let me look closer. Not the most amazing way of looking at this, but these are my two main modes, my two main areas of interest with this event. And you can see here right around, I believe, this is 21:36 or 3:30 p.m. Little bubbly cumulus field, and these updrafts actually did sustain themselves. With the cold front coming in, a lot of forcing was we had in this region. And that's why we saw a good amount of sustained updrafts right here. We have one right here, and kind of one forming somewhere around this vicinity. And these would begin to sustain themselves as they would move together in a bowing line segment. You can see here right before the sun's completely set, very high storm tops. Let me move to a better color here. Very high storm top. You can see it, even though everything else is dark. Right here, there's one. Right here, here. So all three of these big storms here as they form into the night, and then we lose our coverage. So I should have radar imagery as well. Let me find that real quick. Here's our radar imagery for the event as well. You can see here's our three main updrafts that formed, and as the night went on, these were very tornadic. There was a lot of surface vorticity and 3 cape, which I'll look at the HRRR model as well to show that. Lots of work for this this whole system here, with the cold front being very forcing as well. There's a lot of surface vorticity with this whole system entirely. That's pretty big hail in here. I think we had some 2-inch reports. I believe mostly 1.5 inch, but again, that's definitely severe. And this would eventually become a bowing line segment once it reaches Lake Michigan. With, I believe, actually, this one supercell was able to sustain itself, which I actually got to see some of the supercell as well. So later video though, keep looking for that once it finally comes out. But these sustained storms here, these originally started out, and then once they kind of congealed together, we would end up seeing this bowing line segment, right? You can see this little line kind of forms. Better color for this again. I think could work. Kind of this line segment right here on a line, and as this would kind of move towards the middle, it would kind of bow out a little bit. I press play here. You can see it kind of bows out right there, like I said. And eventually this would also move its way into Michigan, which I looked at the models, also had a lot of 3 cape, and there was instability in Michigan at the time as well. I think that helped sustain a few of these little supercells and tornado reports that were seen that night as well. But the one thing we didn't really see at this event was the Indiana thing. So something to note here. Get back to the spot. I believe our cold front is situated back in here, somewhere along this line, I believe. Let me see. It's not 100% sure in my eyes. I believe it's a little hard to tell right now for me, just looking at the radar imagery. I would need to see the velocity data as well. What we can see here is also this little band, which is also an interesting note. So unfortunately, the media player has this thing here, but you can see down here, there's this area of increased reflectivity. That's kind of indicative of some sort of boundary, probably an outflow boundary, or maybe even cold front as well. You can see it right here. You look right in this vicinity, this little arrow pointing at it, little line right here. And this is kind of what was forming storms that night. But these storms just didn't really go how was originally expected. If we look at the HRRR, it was kind of forecasting these individual discrete supercells moving like so repeatedly along this little segment, which would fit very well with our enhanced risk. Is what we had right here. So these storms would move off. They would kind of form here in very southern Illinois and just move northeast. So we did kind of see that, but just only later at night. I look back at the player. That only really happened once we hit Ohio, and there was just enough updrafts to really sustain something. And I think over here, one of these points. That's where our tornado is forming here. But these were very disorganized, and all we really saw was some isolated hail, or sorry, excuse me, isolated wind threats and a few hail threats as well. So what I'm looking at now is just kind of why did all this happen. I'm going to take the closest HRRR we really can to the event. I'll do 20Z because this is like right before. So again, remember, storms fired around 22Z, which is about 4 p.m. This is like right before the event. This is showing us basically what the environment was looking like. HRRR is very, on point with this, as it always is. Same updrafts that moved through Illinois, although I will say a lot slower than they actually did. At 9 p.m., these storms were already, I believe, over Lake Michigan, and that was done for at that point. I also still showed this, although fairly messier mode, still the supercellular characteristics here in Southwest Indiana and stuff like that. Main reason, though, I think that they had that significant hatched region was because of the STP significant tornado parameter. So I do think it was justified to have that area of, worry and enhanced risk because the significant tornado parameter is off the charts. We're looking at 8s here. I can look at the RAP model as well. For a similar time, it was showing this very prime environment. If anything formed in here, it would be very dangerous. I'll take a sounding from the RAP model, just kind of see what the environment would be if any of these had really, really taken advantage of it. So here's our photograph. We have 104 joules per kilogram of 3 Cape. It's definitely very much good instability in the lower levels of the atmosphere. Any vorticity at the surface would be stretched vertically, and that's kind of where our tornado formation is. Surface vorticity kind of on little front lines can happen quite a bit. And with 3 Cape like this, that will be just pulled up, and that's kind of where we get our tornadoes to actually form. We have 100, I think, sorry, not 100,000 joules per kilogram of Cape above, especially surface-based. The surface-based here shows a little more capping in store. That's definitely something to note with that environment, which I think might have helped keep people safe in the southern portion of this event. The photograph is also very good. Lots of lower level turning, backing in the mid levels, around 1 kilometer, 2 kilometer right here. So kind of backs, not always what you want to see, not at that severe backing, but it is still there. And then it jets off any precipitation this way. So turning to low levels and then jet off precipitation. So it would be good for discrete supercells. This is also why we had that huge plume of the significant tornado parameter. I really think that might be like the main reason they really put up that, the whole risk. I think another sounding as well. But there was definitely Cape to be had here, and if it was stretched in the vertical, lots of 3 Cape was involved. Just across that entire boundary, especially here later into the night. So definitely interesting to know. Again, similar thing with this other sounding I've taken here. 105 joules per kilogram. Very similar sounding as well. So yeah. That's kind of our environment for the Indiana area. But I think, again, we looked at the radar loop. I'll watch it one more time. It's a little hard to see. But I think there just must not have been enough forcing here. I think maybe it just got so messy and there wasn't really enough vorticity that nothing really sustained itself upward to really create good tornadoes for that whole region. But definitely a good thing, because this event did look very potent, what we were looking at. So yeah, you can see that definitely missed in the southern portion of the event, but I think it's just because we didn't really see those lines of storms in this region over and over and over again. And again, the main thing I wanted to note in my forecasting of this event, what I focused on a lot was what I wanted to see for like a storm chasing perspective, which was something forming right along here, a little convergence band somewhere in this vicinity in eastern Illinois. So what I failed to look at a little bit more was really the cold front threat, because cold fronts can still have tornadoes. I mean, we did see that. Usually you don't think of cold fronts as being as tornadic just because of the fact that they're so forcing. You don't really get discrete updrafts. But I will say something I failed to look at with this event is the fact that there was a lot of vorticity right along this cold front. You can see it on the HRRR here. Lots of vorticity in this region and a lot of 3 Cape too. I think it's 221. That is absurd amounts of 3 Cape with this RAP model here. HRRR is probably show something similar, even more vorticity as well. So the amount of 3 Cape, even just being above 50, is just enough to stretch anything into the vertical. You look at this and you wouldn't be too impressed, but you have that lower level turning just a little bit, and that's enough to really get anything forming stretched up. And uh, 153 joules per kilogram of 3 cape is just plenty to work with. Not to mention this is a fully capped environment too, very saturated. The storms will be ingesting a lot of moist air here. I think this might be slightly convectively induced just because of it's probably like assuming there's a storm ongoing here. That's not the color. Assuming there's a storm going on here, so this is all cloud cover basically going on. But yeah, kind of how our storm would look like. But I really failed to take into account all that, so that's something I need to work on more so in the future. And you can see here again, Michigan had a lot of 3 cape in the night as well. And that surface vorticity, those pair together. When those pair together, that means that's where tornadoes can really happen. The HRRR model shows us around 6Z. I believe if we see the storm reports, might show something similar. Let's see. Yeah, right around 6Z, 5Z, and 530Z right there, and 6Z again. So just like the HRRR showed here, and another that plume right here. Check this again. Much more east, but again, there's just a lot of cape still to be had in this region. Mean layer cape basically spread all over, most unstable as well, just completely spread over Michigan. So anything that could take advantage of this environment would. Significant tornado parameter. You can see a little blotches right there as well. I don't look at that too much. I'm trying not to. And plenty of 3 cape over entirety of Michigan. So that's part of why we saw those tornadoes there as well. I think with the Indiana threat, that was just kind of luck for the people there. There could have been tornadoes there. I don't think we saw anything, but these hail reports we saw. Let's see if we can zoom in here. Hail reports here, those could have been tornadic initially, but might not have been people there to see them. So never really know on that front. But yeah, this is a very messy taskbar I have up here, but you kind of get the point of what I was trying to make this video. So we had our whole event. The cold front was definitely more severe than I had originally anticipated. Not to mention this is a very, very wound up surface low. 988 in the center of it. So I also forgot to make a video. I didn't really have a chance to make the video before this event really happened. So I do apologize for that. I was also very focused on getting to school and if I was gonna chase. But this is what I looked at. This is kind of a little update of what I did look at that day as well. I also forgot to mention that I didn't really look too much into the threats after the day of. Really precipitation here. I'm gonna go to 0Z for 0Z for 6 p.m. February 27th. I didn't really look too much into the threat the next day too much either, because it was mainly wind, which is fair, but I should always be looking at these threats just to kind of get better at my own improvements. Just with this whole science as a whole, considering that is what I want to do and the point of this channel as a whole. So, other than that, I think this is about it for this video. Again, mostly just a little bit of a looking at what I see. I mean, what could I have done better myself? Probably, I need to look more at what is objectively going to happen and not so what I am thinking is going to happen. But I will say, I did have some success with this southern mode here. Even though nothing actually formed there, I was correct in looking at it and saying, hey, I think something might happen there. There was too much cloud cover basically the whole day. So from about 9 p.m. to, I think 2 p.m., there's just basically steady clouds over all of eastern Illinois, continually. So, say those had not been there, there definitely would have been a line or some storms forming right in this little vicinity here, moving on northeast, which would have been way more chaseable. But I do think I was right to have not chased that day. So, even though there is a little bit of footage from the night, so I'll get into a video that is going to be coming out pretty soon as well. So, stay tuned for that video in the future. But otherwise, that's it for this video. So, thank you for watching, and I'll see you next time.